My name is Kathy, and I'm a biomedical technology student. Now, I have a very, very inquisitive mind, and I hope you do too. Now, have you wondered what actually goes on in the lab when your blood is taken from you for blood typing? Do you know what blood types you are? And if you do you actually know what actually happens in the lab, the procedures and the tests that go on in your blood to actually determine the blood type that you actually are? And if you said yes to any of these questions, come closer, let me show you how it actually happens. Quite simply, actually. So now, they take the blood that they withdraw from you is centrifuged. Now, centrifuge is another word, fancy word, just to say your red blood cells are separated from your plasma. Now, this is done because we want to analyze your red blood cells. So we remove the plasma from the red blood cells. Now, when this is done to your blood specimen, we remove the plasma and put it in a separate test tube for later purposes. And then again, we take the red blood cell, some of it, and we put it in a separate test tube. Now, your plasma and your red blood cells are separated. Now, what we do to the red blood cells that we extracted from the centrifuge blood specimen, we take it and we mix it with saline. Now, saline is another solution that we use to wash the red blood cells. Now, why do we need to wash the red blood cells? We do it to make sure that we eradicate any plasma that could be present in your red blood cell. Now, why do we remove the plasma? Because plasma could have antibodies. Now, we just want to analyze a pure solution of red blood cells. So we wash it. So we add the saline up to maybe almost to the rim of the test tube, and we mix it, and it is centrifuged. Now, when it comes back from centrifugation, what happens is it comes out as beautiful as this. You get your saline at the top and your washed red blood cells at the bottom. Now we remove the saline, the supernatant, the saline out there, we remove it and we add clean saline again up to there again, tilt it once and we return it to the centrifuge machine. Now, we do this, we wash it 3 times. Yeah, 3 times. Now, I know it may seem like a nuisance, but your life is at stake. So what we do now, when we centrifuge it 3 times, we just have to make sure that all the blood plasma is eradicated from your red blood cell solution. So what happens now? We do this 3 times, and then when this is done, we remove the saline, the supernatant. The saline, we remove it again. We add clean saline. We mix it nicely again to get your red blood cell suspension. Now, when you have your red blood cell suspension, it has to be red, not crimson red, but then light, bright red. Now, that when it's that beautiful, you take it and we can start analyzing it. Now, this is what happens. We label 5 test tubes A, B, O, and small a and small b. Now, the first 3 test tubes are there to test for possible antigens that could be present in your red blood suspension. So what we do now, so I say your A, B, and O are there to test for the antigens that could be present in your red blood specimen, and your A, small b, the last 2 test tubes are there to test for antibodies that could be present in your blood plasma. So what happens now is on your big first 3 test tubes, your A, B, O, you label them like that respectively. You add a drop of red blood cell suspension on A. Test tube B, you add another drop there, and test tube O, you add another drop there. Now, on test tube small a and small b, you will not add your red blood specimen, suspension, but you will add your blood plasma. Now, remember at the beginning, we took the blood plasma from a centrifuged blood specimen. So now we take it, we add 1 drop on each test tube, and then at the bottom here we have in the table reagents. Now on your First test tube where it's labeled A, you will add anti-A reagent. On your test tube labeled B, you will add anti-A reagent. On your test tube that's labeled O, you will add anti-A B reagent. Now on your small a, you will add a drop, just a drop of a known blood type. So you will add blood cells A on your small a, and on test tube B, small b, you will add a drop of B blood cells. Now you leave these 5 test tubes to incubate for 5 minutes. You leave them to incubate for 5 minutes, and then after 5 minutes you come back and you analyze for agglutination. Now what you do is, on the example that I showed you before you, my patient's blood reflected the following. On the big test tube A, remember big A, B, and O test for antigens. Now antigens present show the blood type. The antigens present show the blood type. So what happens is, I analyzed and saw blood type on test tube A was positive. I received positive agglutination for blood type O. And on my small a and small b test tubes, they were both negative. There was no agglutination. Now this is how you see if your solution did actually agglutinate. What happens is, you see clumping or particles on your small solution are right there. No matter how vigorously you shake it, you will still have the clumps or the particles right there. So that's how you see agglutination. Now under the microscope, this is actually what happens underneath. This is your red blood cell, the ones that we were analyzing, and these are antibodies. Now, for agglutination to occur, antibodies bind to red blood cells. Now this is how it actually happens. Here is an example of how antibodies bind to the red blood cell, and that is agglutination. So now you know that if you are a blood type A, you will have antigen A and antibody B. And if you're a blood type B, you will have B antigens and antibody A. But if you're an O blood type, you will have both antigens A and B, but you will not have any antibodies. Now this is how your blood type is determined. Thank you very much for listening.